Hey guys, so this is the second part of the unit. We have inverse operations to talk about. So there's a really long definition of inverse operations, two operations that will be performed on a number or variable that always result in the original number or variable. In other words, this is the part that I would write down if I were taking notes. Two operations that undo each other. So like the ones that you guys know that are most well known actually are addition and subtraction and multiplication and division. So addition undoes subtraction and multiplication undoes division. So here's some examples of those. If we wanted to undo the subtraction that's happening here in this first problem, we would need to add. So I'm going to be adding as an inverse operation. So I'm going to add 2 to both sides. And I'm just going to end up with x equals 8. So here I added to undo subtraction. Over in the next one, I'm going to subtract to undo addition. We would subtract 7 from both sides because we need to subtract to undo the addition, right? Alright, on this next one, it's dividing by 4. This little line means divide. So if we want to undo division, we're going to multiply. And here's a big hint for all of you out there. Multiply is the only operation, multiplication, is the only operation that is not explicitly written. In other words, it's the only one that you don't have to write. So like when we divide, we draw a divide line. When we add, we write a plus sign. When we subtract, we write a minus sign. When we multiply, we don't actually write a multiplication sign. So here, if we multiply both sides by 4, that 4 would then go away. It would go to a 1. So then there would only be 1x. If you notice up here, this went to 0, so it was 1x plus 0. Over here, this became a 0, so it was x plus 0, so x was all alone. On this last one, you'll notice, again, the multiplication is the only operation that does not explicitly say it's written. So this is actually 3 times x, so then we would divide to undo it. And then we would divide both sides by 3. Hopefully you're feeling okay about that. It's just solving. So starting from here, we're going to practice these problems. And the first thing we need to remember is how many degrees does each of the inside angles of a triangle add up to? This is in your notes. So the angles of a triangle add to 180 degrees. So that means I would have 30 plus x plus 30 plus 9x equals 180. So from here I need to combine like terms. So I've got a 30 and a 30 that I can combine and get 60. Then I have an x and a 9x I can combine and I get plus 10x equals 180. So from here I can then subtract my 60 because this is a positive 60 or it's adding to 10x. So if I subtract it, I'm undoing that. And I get 10x equals, then 180 minus 60 is 120. Then if I divide both sides by 10, I get x equals 12. Alright, so the next example problem that I want to do, so then I want you guys to try this one out, but before you try that out, I'm going to do this one, which is similar, but now it's a quadrilateral. So some of you might know this, some of you might not. As quadrilateral, the angles of a quadrilateral always will add up to 360 degrees. So here I can rewrite this as 50 plus 2x plus 30 plus 2x plus 20 plus x equals 360. So I'm going to go through and find all the like terms. So I know I have a 50, a 30, and a 20 that can all be combined, so that becomes an 80. And then I have a 2x, a 2x, and an x, so that would be plus 5x equals 360. So from here I would subtract 80 from both sides. And 360 minus 80, so we'd have 5x equals 280. Then from here we would divide both sides by 5. And we would get x equals 56. Alright, so that's how you do the triangle one. Remember, these ones add to 180. And these ones with the quadrilateral add to 360. So go ahead and solve those two. Then write your recap, and you are done for the day. Fantastic. Thank you so much.